the first thing that you're supposed to be asking me is about the content, because we are looking on the quantitative analysis. Quantitative analysis. And the content that we have to be checking on is very simple. The content in which you are supposed to be working on. Now, there are some of the things that you have to be checking on. Number A, we are discussing about functions, right? Functions. I will be able to teach you one of the important aspects of functions, which is the application of functions. Functions. We are going to be also be checking on the contractic equations. Quadratic equations. We are also going to be learning about calculus. And when we discuss about calculus, it's subdivided into two. We are going to be looking on the differentiation. And then we have integration. That is the thing that we're going to be checking on there. When we go to part B, or the second topic, we are going to be looking on the matrix algebra. And when you look on the matrix algebra, there are aspects in which you have to be looking on matrices. We are going to be looking on 3 or 4 major areas. We have to be looking on the matrix operations. We have to be looking on input-output analysis, right? Then number 3, we have to be checking on Markov analysis. These are the areas. Markov analysis. I know very well you understand this is the area where the examiner normally targets a lot. Then we go number C, where we are going to be doing descriptive statistics. Descriptive statistics, which was the new topic, I think, which were introduced under the new syllabus. Then number D, you will be able to do something called probability. When I look on the probability, I normally look on 2 areas here. One, you have to be looking on the set theory. Now, the set theory that I'm going to be doing, it is important to do set operations. Let me talk about the operations of sets. When you come out of that, we are going to be looking on probability distributions. I'm very aware that you know under the probability distributions is normally subdivided into 2. One, we normally have discrete probability distributions, and then we normally have continuous probability distributions. This is the area also the examiner was able to focus his attention last semester. And you remember when you talk about the discrete is normally subdivided into uniform, right? We normally have uniform probability distributions. We normally have binomial probability, and then we normally have Poisson. When you come to the continuous, we normally have uniform, yes. We normally have uniform. We normally have normal probability distribution, which is mostly used. Then the last one will be, right, exponential probability distributions. Those are the things that we shall be able to focus our attention when we are doing the probabilities. After the probability, we are going to be looking on the hypothesis. Hypothesis testing is a topic of its own. One of the key important, I saw some question of hypothesis testing, right? Where we are going to be looking on type 1 error. And then we're going to be looking on type 2 errors. This means it's a one tail, and then here we talk about 2 tail, right? We are going to be looking on those things as we continue to finalize our syllabuses. Number F, we have to be looking on the correlation and regression analysis. And one of the key important areas here which we are supposed to be focusing our attention is appraising. Appraising regression models. Remember the model that you're going to be formulating, they are supposed to be in form of y is equals to a plus bx. They are supposed to be taking linear equations. Then we are going to be looking on G, which is time series. Time series is very simple since the examiner wants you to understand about the models, decomposition models, which are mostly used. We normally use mostly two: additive model. Then we normally use multiplicative model. Those are the two things that we have to be looking at there. Then F, which was already minimized, we are going to be looking on the linear programming, right? Linear programming, I just want to analyze two things here. We are going to be looking on two methods which are used to distribute the resources which are applicable. Here we normally use the concept of scarce resources. In this case, we have to be looking on the graphical method, which I think was there in the exam, or we have simplex method. Those are the two things. Then the last one, G, F, F, G, H, I, we are going to be looking on the decision theory. Decision theories is where we normally look on the three environments when the decisions are normally made. We normally look on the environment of risk. We have environment of certainty. We have environment of uncertainty. Then we normally have environment of competition. Those are the things that we shall be able to analyze. That is your full syllabus. Very simple. I just want to start by looking on the functions, right? I finished function right now, and then I look on whether I can be able to introduce the matrix algebra. I know the function is one of the simplest, but it has never missed in any exam. It doesn't miss. In any exam, the function will always be there. Always be there. A minute, please. A minute.
Okay.
Let us look on functions now, right? Functions, yeah, which is our first content, which we have to be analyzing very well. They are very simple things which are basically going to be applying some concepts that we will not supposed to be forgetting them because they are mostly used moving forward. Now, when you look on the functions, it's just a mathematical relationship which shows the connectivity between two variables, right? When you talk about two variables here, we are going to be looking on two things. We are going to be looking on independent variable, and then we are going to be having dependent variables. Now, in this case, because we are discussing only two, we have to be analyzing what is a dependent, what is a variable, and so on. Now, if, for instance, we can start by looking on the terms which are basically used here, we are starting with variables. Terms used. So the term that is firstly is mostly used, we are going to be analyzing our variables, right? When I look on the variables is very clear, and we say that the variable is just a subject of analysis, right? A variable will just be a subject of analysis, which will be able to keep changing throughout the analysis, all right? It is a subject of analysis which keeps on changing throughout the analysis. Right? So when we are discussing about the two variables, remember we have already analyzed the independent variable. Independent variable. Independent variable, we are saying this, right? Independent variable, we are saying it is just a variable which causes the change in the other variables. And it is a variable which causes change in the other variables. And it is normally placed along the x-axis. The examples of the independent variable, which is going to be assisting you when you are calculating your regression and correlation analysis to differentiate between the independent and dependent variable, you have to be analyzing this to be time. We have hours, right? Time, hours, days. We have months. We have years, etc. When you're analyzing about dependent variables, when you look on the examples, because it is normally placed along the y-axis, and it's the variable which is going to be changing as a result of changes in the other variables, it will be including, we have costs, we have profits, right? Cost, we have profits, we have revenues, etc. Those are the two things that you have to be looking on there. The other term which is basically used, it is normally called constants. Something that is constant is the subject of analysis, which does not change. Because here we say this, it is the subject of analysis which keeps on changing, right? Here we are saying it is a subject of analysis which does not change. Does not change throughout the analysis. Throughout the analysis. Now, I just want to look on the applications of functions. Application of functions, right? Application of functions. For example, in business, because that is the question that the examiner will be able to ask you. Application of functions in business. Number one, you can talk about accounting for non-current assets. Accounting for non-current assets. Number two, we are going to be saying computation of sales earnings. Computations of sales earnings. Number three, we normally look on cost volume profit analysis. It is normally called CVP analysis, which you are saying that cost volume profit analysis, right? CVP analysis. Then number four, and the last one, which is very interesting, is the determination of market equilibrium. Determination of the market equilibrium. Now, when I look on the first one, this one is not tested and there is no need of wasting my time there. I just want to look on the last three, right? These one are mostly examinable. So when you look on the computation of sales earning, you will be able to analyze that a salesperson are normally paid a fixed salary, which is the basic, and a commission, which is normally based on the number of units which they are going to be selling. So in this case, the examiner will ask you about the total earnings, which will tell this examiner to get your total earnings, take your basic salary, right? Plus total commission. That is how we normally compute the total earnings of a salesperson. Now, in this case, if you analyze it in maths, in mathematical aspect, you say E is equals to B plus VQ, right? When you talk about V is the rate of commission. That is the rate of commission. V, it is the rate of commission. V, it is our rate of commission. Now, I just want to look on a good illustration here. It does not mean that the examiner did not want us to sort it using the functions, using this formula, but we normally use it to make sure that you understand on how you can be able to compute the sales earning. The question is directly attributed to matrices, where the examiner was saying you use the matrix algebra to solve the equation. So the question is basically in 2019, May 2019. Let us start from that end. May 2019. So let us go back to our, I know that you have your link for these questions, and you are going to be reading the question for me. So in this case, we are discussing about May 2019, question 1B. Quantitative analysis was one of the senior unit in section 4. They demoted it. They demoted it. Question 1B. They demoted it down here. Question 1B. Read the question, please.
Question 1.
B.
A salesman earns a fixed monthly basic salary and a commission that is directly proportional to the number of units sold in the month. During the months of February 2019 and March 2019, the salesman's total earnings were 60,000 and 70,000 respectively. The number of units sold by the salesman in the month of February 2019 and March 2019 were 100 and 250 respectively. During the month of April 2019, the salesman sold 400 units. Required, using matrix algebra, determine 1. The fixed monthly basic salary of the salesman. 2. Commission earned per unit sold. 3. Total earnings of the salesman in the month of April 2019.
Very good. It is a very good question when you look at it. And in this aspect, you have to be checking on what are the areas in which I am supposed to be exploring in the question. 1, I have to be understanding that to get my total earnings, we have to be taking the basic salary for a total commission. Total commission there. Now, when I look on this examiner or this question, the examiner has already given me, right? The examiner has already given me the 2 months where the total earnings were earned. For example, in the month of February, we have been told he got 60,000, which is equals to B, plus we were being given the number of units because you know our Q, right? These are the number of units. Now, in this sense, you have to be understanding in February, they were able to sell 100 units. It will be 100B because the rate of commission we don't know. When we go to the March, right, you got a total commission of 70,000, right, which is equivalent to the basic salary is unknown, plus he was able to sell 250 units. Once you subtract, you eliminate B, right? So in this case, it means this negative 10,000, which is equals to negative 150 V, divided by negative 150, divided by negative 150. So to get the rate of commission, right, is the rate of commission, which will be equal to, take your calculator, please. The rate of commission will be 10,000 divided by 150, and we are getting 67. These are Kenya shillings. 67 Kenya shillings. Then we go back and substitute, you say, substituting for B now, because B is you don't know the rate of the basic salary. I say 60,000 is equals to B, which is unknown, plus 100. But the rate for B is unknown, which is 67, right? So in this case, you say 6,000 is equals to B plus 6,700. B will be equal to what? Take this to the other side here. You say 60,000 minus 67. It changes the sign once it crosses the equal sign. So 60,000 minus 6,700. We are getting Kenya shillings 53,300. But there is only one thing that the examiner is asking: the total earnings of the salesman in the month of April 2019. So it means in the month of April, the salesman was able to get, because already you have the basic salary and then you have the rate, the examiner has given you the quantity for 400. To get the total earnings now, right? Total earnings, I just need to say, let me take my basic salary, which is at 53,300, plus what? Plus what? The rate of commission you have gotten 67, but you multiply by 400, the number of units that he was able to sell for the month of April. So 67 plus 400 plus 53,300. You are getting 67, right, times 400 plus 53,300. You are getting Kenya shillings
80,100.
Very good. 80,100. Very simple concept. Very simple concept. But from there, I just want to look on another application of functions in business. And another number, because already you have seen on how to calculate the sales commissions, we have to be looking on this concept here. We are calling it, right? Number 3 now. Number three, we have to be looking on the determination of the market equilibrium. Determination of market equilibrium. Determination of the market equilibrium. Very simple. When you look on the determination of the market equilibrium, we are saying it's just a point of consensus between supply and consumer of a given commodity. And we normally say at market equilibrium, right? At the market equilibrium, we are being told the supply function should be equal. Supply function should be equal to the demand function. Should be equal to the demand function. Now, in this case, it means the supply, at equilibrium, the supply should be equal to the demand, right? So, because we are not reading that, the formula used here, the formula the formula which is going to be used here, we normally say P is equals to A plus BQ, right? Where our P is equals to what? Our P is the selling price. Our A, we normally discuss about, it is a constant. Then B, it is a slope. Sometimes we call it gradient, right? Then we have Q, which is the number of units. Number of units sold. The number of units sold. Now, I just want to look on the illustration. It doesn't mean that the question will be fully done, but there is this concept which we normally use to determine the price function, right? To determine the price function. So in this analogy, we are going to be looking on a question. Let's look on a question here. I think it is the last semester's question, which applied this concept rather than the one that we did last semester, September 2015, question 1C. Let us look on 2022. There must be a question applying this knowledge. Right, quantitative analysis here. Let us check. We had a very good exam here. Very good exam. So the question rather is on 2021, and it should be question 3B. The question of the marketing department of Jacuzzi Limited, you can just read for me, please. Question is there with you?
3B.
Yes.
The marketing department of Jacuzzi Limited estimate the daily demand function of one of its products to be linear in nature. If the price was fixed at shillings 570, the daily demand will be 400 units. If the price was increased to shillings 820, and the daily sales will drop to 200 units. The production department has indicated that the marginal cost of producing Q units of the product is given by the following equation. MC is equal to 2Q.
Let us reach at that point. We are not supposed to be looking on the marginal cost functions. I just wanted to look on the first paragraph. So the marketing department of Jacuzzi Limited just made the daily demand function of one of these products to be linear in nature. If the price was just fixed at 570, the daily demand would be 400. And if the price is just increased to 820, the daily sales would drop to 200. That is sure. That is for sure. Now, in this case, this is how you normally do your price function. This is how you do your price function. So in this scenario, the price function will be looking like this. I just need to write my formula to give P should be equal to A plus BQ, right? Now we are being given the price functions here, right? The examiner has already given you the prices, variations. We are being told very well, if the price is just be fixed at 570, right? 570. We should be equal to A because we said A is constant. The number of units, which is our Q, the daily demand will be 400B. Because our B we said is a slope. Now, what about if the price is increased to 820, which is equals to A? The number of units will be able to drop to 200. Once you reach there, just subtract to eliminate one unknown. It means here you're going to be having 200B, which is equals to, when you take 570, 570 minus 820, I'm getting negative 250. Divide here by 200 and here by 200. So it means my B should be equal to what? Negative 1.25. Very good. Negative 1.25. And then you say substituting. Substituting for what? Substituting for A, which is not known here. Now in this case, they say 570 should be equal to A plus 400 times negative 1.25. Right? So 400 times answer, right? We are getting negative 500. So A minus 500 is equal to 570. So our A should be equal to 570 plus 500, which is equal to 1070. So the price functions will be looking like what? You take the constant of 1070, right? Minus 1.25, 1.25, yes, Q. 1.25 Q. That is your price function. That is your price function. Very simple. Very simple. Now, that is just the knowledge that you have to be applying. To apply the same knowledge, you can go and do September 2015. It is the same. Up to that point, September 2015, it applied the same concept. September 2015, question 1C. Question 1C. The same. You just need to determine the price function. Don't do that question beyond that level, right? Because you have not reached an area where you have to be solving that question beyond that rate, Now, the other thing that I just want to teach you is the last application. The last application here, right? The last application. We are discussing about number 4, which is the cost, volume, profit analysis. CVP analysis. CVP analysis. Very simple concept. Why? Why am I saying simple? It is very simple in this manner. Can you be able to see my board?
Yes.
Very good. It is simple in this manner. Right, a minute, please. Good. Now, when I look at it, the CVP is a good analysis, even at the work where you normally work, at your place of work. In this case, it means I have to be looking on the cost which I have to incur. Once I look on the cost that we are incurring, look on the number of the units that you have to be producing, right? If the number of the units you are able to determine, then look on the profit in which you are going to be reporting. You're going to be reporting. So this concept at least makes me to understand very well. In an advanced level, the cost will be my my dependent variable, because the more I spend, the more the number of the units I will be able to produce. And if I have a ready market, the more the profit I'm going to be generating at the end of the day. So we have some assumptions for the CVP. I will be able to share with you those notes for you to be able to factor those. But the most important thing that you need to understand here is the CVP functions. So the first one is the revenue function. The revenue function is normally denoted by R. And we are saying to get our R, we normally take P times Q, where our P is the selling prices. Our Q now, these are the number of units sold. Number of units sold. Number of units sold. When you go to number 2, we normally look on the total cost function, which is our TC, right? You just say, to get my TC, I need to take, because these are total costs, you take the fixed cost, denoted by F, plus variable cost of hours, which is VQ, right? Where we are discussing about the V, it is the variable cost per unit. Then when you look on the Q, these are the units produced. The units produced. When you look on the 2, this is the revenue generated. So we have to say, this is the total cost we have to produce. Number 3, we have profit function. Our profit function now. Our profit function there. So you ask yourself, how are we going to be getting the profit? Sometime there before, we used to say the total revenue minus total cost. Or we can use, to get my profit, I use contribution margin X minus fixed costs, right? We say where, right? CM, this is the contribution margin. That is my contribution margin, right? X, these are the number of units sold because you are generating your profit. Then F is your total fixed cost. Total fixed cost. Now, you have to be looking on one concept here, break-even point. Break-even point. And I say, a break-even, this is a point where the total revenue is equal to the total cost, right? It means our profit is equivalent to 0. The profit is equivalent to 0. So in this case, I say 0 is equal to the contribution margin X minus fixed cost. Now in this concept, we say, let's make X, because we want to determine the number of units required to break even within the organization, make X the subject. Take this on the other side. So F should be equal to the contribution margin X divided by CM divided by CM. So our X should be F over CM. And this is when we discuss about the number of units required to break even. Number of units required to break even. That is how you're going to be getting them. Now, the other thing that I just want you to know very well, right? The other thing that I just want you to know under these functions, it is the contractic functions. Contractic functions. Before we do any questions, you have to be understanding these concepts. Right? So we look on the contractic functions. Right? Just ask yourself, what is a contractic function? Right? A contractic function. And I will be able to tell you, these are the second degree polynomial. They are the second degree. They are the second degree polynomial. They are the second degree polynomial. And in this case, we are saying that they have the general form, right? The general form taken here. The general form will be equal to y is equal to ax squared plus bx plus c, right? Ax squared plus bx plus c. Now, in this concept, you have to be analyzing what is my y. And I say, my y is my dependent variable, right? That is my dependent variable. Now we have x squared or x. My OX will be these x's of mine, they are independent variables. Dependent variables. Then we have, right? We have ABC. These are your constants. They are your constant there. You remember during your high school period, we used to have quadratic formula. We used to have quadratic formula where we used to say minus b plus or equal to the root of, right? B squared minus 4ac. Then you divide all over by 2a. 2a. You divide by 2a. That is the formula already. You know you used it somewhere, or you are able to use last semester, but it did not yield any fruit for you. Now this is the time to be able to apply it in a good way. So let us look on the characteristics of contractic functions, which assist us to identify whether the question we are going to be solving is using a contractic equations. So contractic equations, what are some of the characteristics we can be able to look here? We say, number one, they have a turning point. They have a turning point. Number two, right, when you look on this equation, they have two solutions. We have to be looking the one that is going to be maximizing our profit. They have two solutions. Number three, when you look on this, a contractic function is normally defined. A contractic function is defined when 3 points are given on a curve. This point is very important. On a curve, it is very important. When I see a question has already given us, like the question in April 2022, when the 3 points are basically given on a curve, we are going to be using contractic functions. Then we have to be saying the last one, they can be solved using, they can be able to be solved. Number four, they can be solved using, right, contractic formula. Right? We normally have substitution method. We normally have elimination method, among other methods, etc. Let us look on a question of April 2020. It's a very simple concept here. April 2022. I think it should be question number 1. So that we can be able to understand what we mean. Right? April 2022 there. It should be question 1 something. It should be question 1. So let us look at it. Very good. You can see the question here with us. You can check on the question, please. You can read question number 1A.
Hexadol Limited has been in operation for the last 5 years. The company's annual revenue function and annual cost function take the form of quadratic function. The following data was obtained from the records of the company for the last 3 years. We have 2019, 2022, and 2019, 2020, and 2021. Required the revenue function of the company to the cost function of the company.
Very good. So when I look on this question, already I have been given 3 points on a curve. There is 3 points. So you can see we have different number of years. The data is given there. So we are going to be starting with the revenue function straight away. Revenue function here. We're going to be starting with the revenue function. Now, when I look at it here, because you're going to be starting with the revenue function, this is how you're going to be doing, right? Remember your equation, your general formula we used to say, y is equals to ax squared plus bx plus c. Now, your y here, you replace with the total revenue. You say the total revenue is equals to ax squared plus bx plus c there. Now, the total revenue is already given. The revenues for 2019 is 2320, which is equals to our x is the number of units. You can see down there. So 4 squared a, right? Let me just put it direct. So 4 squared is 16a, right? 16a plus now my x, which is 4b plus c. The other one with b, right? Let us go to 2020. The revenue given is 4420, which is equals to, when you look up there, we have h squared, which is 64a plus, right? We add what? We add our 8b plus c. Then when I look on 2021 for revenue, we have 6480, which is equals to, when I look up there is 12 squared, which is 144a plus 12b plus c, right? So when we are discussing about the elimination, take the first equation minus the second equation. We eliminate these unknowns. So we start with 2320, which is equal to 16a plus 4b plus c. Then we have 4420, right? Is equal to 64a plus 8b plus c. Eliminate one unknown now, right? In this case, once you subtract c goes, we remain with negative 4b. Now 16 minus 64, 16 minus 64. You're getting negative 48. Now, which is equals to 2320 minus 4420, which is negative 2100. And because you can see negative is dominating all the areas, you can just write your equation like this. 2100 is equals to 48a plus 4b, and this you call equation 1. Now, let us go to the second work here, which you take the second equation minus the third equation, right? In this case, it means 4420 is equals to 64a plus 8b plus c. Then the last one is 6480, which is equals to 144a plus 12b plus c. Subtract again, eliminate c. This is negative 4b, right? 64 minus 144. I'm getting negative 80, right? A, which is equals to 4420. 4420 minus 6480, and we are getting negative 2060. Again, negative is dominating all through, so you can just say 2060 is equals to 80a plus 4b.
Excuse me.
Yes, yes.
Excuse me, Mwalimu.
Yes, yes.
Excuse me.
I can hear you. Yes, yes. Hello, Eunice?
You are not clear.
Right now, can you be able to see me?
I'm saying you are not clear, but now I can hear you. I'm saying
I can hear you straight away.
hello.
Yes, yes. Hi, Eunice.
Okay, earlier you were not clear, but now I can hear you.
Continue.
Hi.
Can you hear me? So can you be able to identify up to 2060 where we have already reached right now?
Yes.
Very good. So this one becomes our second. That is our second equation there. That is our second equation. Now, in this case, combine equation 1 with equation 2. So equation 1, right? Equation 1 will be 2100 is equals to 48a plus 4b. Equation 2 will be 2060, which is equals to 80a plus 4b. Eliminate your b because it's already b the same right now. B the same. B the same. So eliminate your b. Eliminate your b right now. So it will be 48 minus 80. We get negative 32 here. Negative 32a, right? 2100 minus 2060. We get here 40. Get your value for a. So your a should be equal to what? 40 divided by negative 32, right? You are getting negative 1.25. 1.25. Now let me take one of these equations and substitute for a. For example, the first one, where we are saying substituting for b now. Substituting for b. Now in this case, we are saying 2100 is equal to 48 times negative 1.25 plus 4b. So 48 times negative 1.25, we are getting negative 60. Plus 4b is equal to 2100. So 2100 plus 60 is equal to 4b. So in this case, it means 2160 is equal to 4b. We divide here by 4, here by 4. So our b should be equal to what? 2160 divided by 4. You are getting 540. Getting 540.
540.
Sorry?
540.
Very good. Now I just want to substitute for c. Substituting for c now. Right? Substituting for c. Now in this case, right? In this case, we just need to take one of the equations here, which is 2320. Now, which is equals to 16 times a, our a, which is negative 1.25, plus our b now, which is 540, 4 times 540, plus c. So in this case, it is 2320, which is equals to 16 times negative 1.25, getting negative 20, plus 540 times 4, which is 2160, plus c. Bring them on the other side. 2320 plus 20 minus 2160 is equal to c. Our c should be equal to what? Right? So 2320 minus my answer plus 20. I'm getting 180. Right? Now, to get the total revenue function here will be equal to, let's take the values of the constants. Already you have your a. My a is negative 1.25 x squared. Our b, right? Our b is how much? Our b, we have b given here. Somewhere, where is my b? My b, I got how much? 540 plus 540x plus 180. That is my total revenue function. 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 Now, when we move for total cost functions, already, because I know now the network is very clear. Now, when you look on the total revenue, total cost function, because the examiner was asking for these workings, you do the same work that we have already done. First, come up with your equations. Come up with the equations. That's a very simple concept, right? Very simple concept here. Now, we go to the total cost function and we look on what the examiner has already given you. First, formulate the equations. You formulate the equations. When I look on the total revenue, here now we replace with the total cost on your equations, total cost. Now, the first one for 2019, we are given 10,404, which is equals to, right? Your X will not change, which is 16A plus 4B, right? Plus C. The other one will be 9832, which is equals to, I think it should be 64 plus 8B plus C. Then the last one will be 9272, which is equals to, right, 144A plus, right, 12B plus C plus C. Now, let's first take the first equation minus the second equations. So this one is 10,404, which is equal to 16A plus 4B plus C. Subtract with the second one, which is 9832, which is equal to 64A plus 8B plus C. Eliminate C. Negative 4B, right? This was how much? 16 minus 64. Negative 48. Negative 48A, sorry. Then we have 10,404 minus 9832, which is 572. And this becomes our first equation. You might be
16?
asking why we not eliminate the negative, because this is positive.
Negative 48.
Yes, negative 48. Now, let us go to the second and the third. Subtract 9832, which is equal to 64A plus 8B plus C. 7232.
Hello, Mwalimu.
Yes.
Hello. Hello.
Yes.
Mwalimu, you are not clear. I think Hello.
I can hear you.
Excuse me.
Hi.
You are not.
Hi, Eunice, can you hear me? Hello? Hi, Eunice? Now, we were discussing about the second equation here, right? Which we are taking the second and the third equations, we subtract to eliminate one unknown. So it is 90, what is this? 92, 9832. This should be 9272, which is equals to 144A plus 12B plus C. Eliminates, right? This is negative 4B. 64 minus 144. 64 minus 144, right? We are getting negative 80, which is equals to 9832 minus 9272. We are getting 560. So to get the values of A and B, we have to be eliminating one unknown again. So I'll take 572, which is equals to negative 48A minus 4B. Then the other one will be 560, which is equals to negative 80A minus 4B, right? Now, once I subtract, I will be able to eliminate B, by the way, right? I know you're asking now, put on a calculator minus 4, minus 4, and I'm getting 0, right? But when you take negative 48 minus 80, you are getting that 2A, which is equals to 572 minus 560, which is 12. Divide here by 32, divide here by 32. So my S should be equal to 0.375. 0.375. you say, let me substitute for B. Substituting for B, right? Just substituting for B. In this case, it will be, right? In this case, we say 572 is equals to negative 48. Multiply by 0. Sorry for that.
Excuse me, Mwalimu.
Yes.
I think it is your network, because I think it is your network.
Okay.
Yeah, just check on your network, because my network is full, but the moment you start, okay, when you are talking, I can hear you, but when you are teaching, it's like you are in a slow motion.
Okay, can you just monitor it right now and you tell me? So 572 plus 18, we are getting 590, which is equals to negative 4B minus negative 4 minus negative 4, right? My B is divided by negative 4. We are getting negative 147.5. 147.5. Then we substitute for C. For C, take the first equation here. 10,404, which is equals to 16, you multiply by my A. Here can I see A? Times 0.375 plus B. Now, when you look on this equation, we have 4 times the value of B, which is negative 147.5 plus C. So 10,404 will be equal to 16 times 0.375, which is 6, plus 4 times negative 147.5. As I can see, I'm the problem now. The problem is from my end. I'll be able to rectify as we move on. So the substituting for C, I have said you take the first equation where we are taking 10,404, and we have already having the value of A and B and A and B. So we just need to be able to substitute them from this equation, and you can see that is what we are doing here. Now, in this aspect, we are saying that if you take these values on the other side, it will be 10,404 minus 6 plus 590 should be equal to C. Should be equal to C, right? Take your calculator, do this, and then you give me the summation. So the value of C will be equal to C will be equal to how much? In my calculator, I can see 10,988. 10,988. So the total cost function will be equal to, when I look at my A value, is 0.375 x squared plus, it should be negative here, negative 147.5, right? X plus C, plus, not C, sorry, plus the value of C, which you are able to get how much? 10,988. This is the total revenue function. The total cost function, total cost function, this one. Are you able to understand? Hello?
Hello?
Are you able to hear me?
Yes,
I think
can
you are
hear
able
you.
to understand it. Now, when I look on those were the only two requirements that the examiner was asking you there. Already we have sorted them out. We were able to sort them out, and then it is good for your revision to understand that how to deal with that concept of contractic functions. Now, I just want to shift our gears, right? I just want to shift our gears to marginal analysis. Now, when you look on the marginal analysis, right? Marginal analysis, you can be able to understand that it is just an analysis of the revenue function, cost function, and so on. But let me put them here. we have marginal analysis, right? Marginal analysis here. So it means what you're going to be analyzing here, number one, total revenue function. You take price times quantities. Number two, we have total cost function, not the total cost, but the examiner will be giving you average revenue, which you talk about AR. To get the average revenue, it means the examiner has taken the total revenue, he has divided with quantity. Number three, we have total cost function, where we said we take the fixed plus variable costs. But number four, the examiner will be able to give you average cost. The examiner will be able to give you average costs. To get the average cost, the examiner normally takes the total cost, you divide by the quantity, right? Then number five, we have the marginal analysis, marginal revenue, total revenue. Now I will be able to say if the examiner has given you total revenue or total cost, right? Then we have some aspects here where we discuss about the marginal revenue or marginal cost. This is what the examiner has already given you. So from here to here, we normally do differentiation. Then from here coming back here, we normally do what? Integration.
Excuse me.
Eunice. Hello? Eunice. Now, I was just analyzing the marginal analysis. Can you hear me right now?
Yes.
So the marginal analysis concept, now we have the total revenue. Here we have the price and quantity. We have said the average revenue, where we normally take the total revenue, you divide by the quantity, you can be able to see there. Then we have the total cost. We have said you take the fixed cost, you had the variable component given there. Then we have said the average cost. The examiner will be able to give you the total revenue. You divide the average cost when it is given. The examiner has just meant that it has taken the total cost to divide by the quantity. But when you go to note number 5, we have said this problem is normally given in a question where the examiner has already given you the marginal revenues or cost, and then they are asking for the profit function, where we normally know that to get that you have to be taking the total revenue, which the total revenue minus the total cost. Now, because we are not supposed to be working with the marginal revenue or cost, it means I have to be integrating to get the total revenue or total cost. Now, if, for instance, in some questions, the examiner might be asking the marginal revenue and he has given you the total revenue function, you just need to differentiate. So it means differentiation, it is a concept of, it is just a concept where we have to be doing some, when you are differentiating, it is just concerned with the rate of change of the slope or a curve. And then we basically say it is normally abbreviated as a change in y over change in x, to mean that the change in y with respect to x. But that being said and done, what you need to be able to understand is the formula for differentiation. I know that I'm very clear right now, where we are saying to get the formula for differentiation here, which we are saying change in y over change in x, we should be equal to what? We talk about n, ax, n minus 1. That is the formula we are going to be using. Then it means I have to be dropping my power down. I have to be dropping my powers down there. Then when we have integration now here, integration, it means we are reversing an equation which has already been differentiated. We are reversing an equation which has already differentiated. And in this case, what is important here is to understand the formula for differentiation, right? For integration, sorry. Where we are saying this simple is basically used to mean integration. And we are saying that to integrate now, I can use it there, right? We are going to be reversing our equation. We say ax n plus 1 divided by n plus 1, right? Can you be able to see this? This is the formula for integration, right? So that formula, it means we are going to be using some equations which has already been integrated, which has been differentiated, sorry. Then we reverse them to the original equations. I just want to look now for 2 to 3 questions for functions as we conclude. we shall be able to start with a question we left somewhere, right? There is a question that we left not completed in 2021 December here. 2021 here, there is a question in December. Right, there is a question we were working on there before here in 2021. December here. I think now I'm clear.
Yes, you're clear.
Very good. Now, let's just look on this question. Question number 3B. The question that we have already done. I don't know whether you can be able to remember how we got the price function. Do you remember how we got the price function? All right, the price function there. So in this case, have I shared the question? Not yet.
Not yet.
Very good, it is here. Do you remember how we got the price functions here?
Yes.
What was the price function? What was our price function? To move very quickly, let us do this. Let me just read the question. The marketing department of Jacuzzi Limited estimated the daily demand function of one of its products to be linear in nature. We have been told if the price was fixed at 5,270, the daily demand will be 400 units. But we have been told here, right, if the price was increased to 820, the daily sales would drop to 200. The production department has indicated that the marginal cost of producing Q units of the product is given below. So the first thing that the examiner is looking on there, he is looking for, examiners have given you a good problem there, where he's asking about, where he's able to ask you about the revenue function. And in this case, we have said the first thing that you need to do, right? The first thing to do here, we are supposed to be looking on a price function. So we said we are going to be using the determination of the market equilibrium formula, where we said we are discussing about December 2021, question number 3. Is it B or C? It should be B, right? Question 3B. We say that we are going to be saying our price should be equal to A plus BQ, right? So we have been told that the prices are going to be varying. The price given is 570, which is equal to A by the number of units. If we sell at 570, the number of units will be 400B. The other one will be if the price is increased to 820. We have been told it will be A plus what? It will be A plus 200 units. Once you eliminate, we said, once you eliminate, we'll be able to get 0A. So it will be 200B, which is equals to 570 minus 2820. 570.
250, negative 250.
Very good, negative 250. Divide both sides by 200. So B is equals to what?
Negative 1.25.
Negative 1.25. Now let me substitute for A. Substituting for A. In this case, I say 570 is equals to A plus 400 times negative 1.25. So negative 1.25 times 400, we are getting negative 500, yeah? A is equal to 570. So our A should be equal to 1070. Our price function, we said 1070 minus 1.25. 1.25. The quantity used in the exam, they are using Q. So it should be Q as per my method there. It should be Q. Now, you really need to understand that to get the total revenue function, you need to be taking price times quantity. Your price formula of the price equation, it is 1070 minus 1.25 Q. Right? Yes, Q. So here it will be 1070 Q minus 1.25 Q squared. That is the total revenue function. Now, because we are looking on, that is number one. Number two, the examiner is asking for total cost function, but what we are being given is the marginal cost. The marginal cost basically given here, it is 2Q minus 2Q minus 570. Very simple. Because we are integrating, we say to integrate is AX, n minus n plus 1 divided by n plus 1. Can you be able to see my board? Hello? Hi, Eunice.
Yes.
Very good. So
Hello.
it means the marginal cost, this is an equation which has already been differentiated.
Hello.
Let us integrate. It means you take 2Q, 1 plus 1, because you are increasing the power. Then you divide by the new power, which is 2, minus 570x. Because you know now, it might be power 0. X is power 0 there. So in this case, it means this Q squared minus 570 x, remember this is a variable component, plus the fixed cost is basically given there down. The fixed cost is given as how much? The fixed cost in the question is given as 1100. The fixed cost is given as 1100. Now, when you look on this question, it is very simple to be able to determine the profit function because already I have my total revenue. So number 3, we have been told the maximum profit that the jacuzzi will be able to make. Remember, this is your total cost function. I have the total cost, I have the total revenue, right? The examiner is asking us to be able to determine what? Very simple here. The examiner wants us to get the profit. And I say very simple, to get the profit, I take total revenue minus total costs. And the total revenue is given, or it is calculated here. 1070Q minus 1.25 Q squared, right? Minus, right? We are subtracting what? We are subtracting that minus 570x, 570Q, this should be Q, sorry. Right? Should be Q squared minus 570Q plus 1100. Like that. Put the like sums together. Put the like sums together. Now in this case, right? In this case, we say 1070Q minus, you're getting positive 570Q, right? Then when you come to negative 1.25Q, I think we should finish only this question and therefore we shall continue from there next time because I don't know what is the problem. So let us just finish this question and then we continue from there next time.
Okay.
Now, in this case, remember this is a profit function, but the examiner wants us to determine the maximum profit. So in this case, it means the first thing that you are supposed to be doing once you get a profit function and that question arises, I will be able to tell you for free, differentiate profit function. Differentiate profit function in that manner, right? Now, in this case, to differentiate, we say to differentiate because the change in profit over change in Q now, we should be equal to what? We are talking about 1640. Once you take the power down here, the power is 1. That is why I'm writing straight away 1640. Q 1 minus 1, right? Minus 2.25. Bring the power down here times 2 Q2 minus 1. This one does not have any power. Does not have any power, and therefore you put it away. Then we equate to 0 now. In this case, it means 1640 minus 2.25 times 2 2.25 times 2, we are getting how much? 4.5 Q, which is equals to 0. Get the value of Q. Get the value of Q. And in this case, I take just the 4.5 on the other side, which is equal to 1640. Divided by 4.5, divided by 4.5. How much is my Q? You're getting 364.4. So remember the examiner was asking the maximum profits. Maximum profits. So take your profit function and then replace the value of Q. Replace the value of Q. Now in this case, it will be 1640 times the value of Q now, Q. Your Q is 364.44. Plus, right? It's not plus but minus 2.2. So 2.25 times 364.44 squared. We are getting 298. 298, 837 minus 1100. So to get your profit, you take 597, 681.6 minus answer, and you are getting the total profit to be 297, 744.44. 744.44. 744.44. Have you understood? Have you understood? Hello?
Yes.
So let us start
Yes.
at that point. Next time, if
Hello.
yes, I can hear you.